All right, welcome to Unit 4, Lesson 2, half a square. We're going to investigate the diagonal of a square, but to begin with, we're going to look at the diagonal of rectangles. So on the intro, the warm-up 2.1, I want you to calculate the value of x in the first rectangle and calculate the value of y in the second rectangle. So if you go ahead and pause the video for a second and find those values. All right, hopefully you've gone ahead and done that. So notice that the two triangles that we're looking at are indeed similar triangles to each other because they both have a right angle and they both have an angle that's 29.7. So by angle, they are similar. And you also maybe notice that the scale factor would be 2. So if you use the Pythagorean theorem to find the first length, the x length, it would be the square root of 65 or a little over 8, about 8.1 if you rounded it off. And then y would be double that. But if you also use the Pythagorean theorem on that, you would see that it is indeed going to be double what that one was. Okay, so just a little warm up on that. So now we're going to take a look at 2.2. We're going to draw some squares, and it says to draw a square of side length 1 centimeter. So I want you to think about a square that's 1 centimeter. Maybe you don't need to draw it, or you could draw a square that was 1 inch on a side and be able to either measure the length of the diagonal or calculate it with the Pythagorean theorem, or maybe do both. But you can hopefully see that the length of that diagonal, if you measured it, is going to be about 1.4 centimeters. And if you did the Pythagorean theorem, you could see that it is the square root of 2, which is approximately 1.4. So then go ahead and do this square that has a different side length. So maybe 5 units on a side or 4 units on a side. And then calculate and figure out that what is the length of its diagonal. So again, do a couple of those and pause the video, we'll work on those, and then we'll talk about it. All right. So if you did a square that was 5 units on a side, the length of the diagonal would be the square root of 50, which is a little over 7. And that would be actually 5 times that 1.4, or 1.414 if you want to get a little bit more accurate on that, from the triangle that was 1 unit on a side. Or, as we call it, we're going to talk about it not as 1.4, but rather as the square root of 2, because that is an unrounded exact value for the length of that. So if it's 5 units on a side, the length of the diagonal, or the hypotenuse, is 5 times the square root of 2. If it was 4 units on a side on your square, the diagonal would be 4 times the square root of 2. It would be the square root of 32. And again, that would become 4 times the square root of 2. So hopefully your conjecture was that it was always going to be whatever that side length is times the square root of 2, or times that 1.414. So as we generalize that now, if we look at the first triangle here, if it's 3 units on a side in that triangle, the hypotenuse, or like the diagonal of the square, would be 3 times the square root of 2. In this case, it's 14 units here, but this other side would also be 14 units because a 45-degree angle here makes angle R also 45 degrees. So it's an isosceles triangle And then the hypotenuse RP would be 14 times the square root of 2. And then what would we do to find the other two sides over here? So on the first ones, if we knew the leg, we multiplied it by the square root of 2 to get to that. So now if we know the hypotenuse, what do we need to do to find the leg? So, all right. So if we multiplied when we knew the leg, this time we're going to divide. So we're going to use the inverse operation. So the length of these two sides would be 24 divided by the square root of 2. Again, I don't want you to do the decimal values. I just want you to think about it this way. So as we scroll down here, if the triangle has a side of 1 unit on each leg, then the hypotenuse is the square root of 2. And again, we want to think of it like that. So if it's x units on a side, it's going to be x times the square root of 2 because it's a similar triangle to the one that is 1 unit on a side. If it's 6 units for a leg, the other unit leg would be 6, and the hypotenuse would be 6 times the square root of 2. This is what we call a 45, 45, 90 right triangle because those are the three angles in it. And if we know the hypotenuse, to find the leg, we would divide it by the square root of 2. All right, that's the end of this lesson. So go ahead and do the practice problems, and hopefully that'll go well as well. Thank you.